Good evening one and all. Welcome to Design of Machine Elements Learning Series, Series 7, Geometric Dimensioning and Tolerances. The objective of this presentation is to understand the significance of geometric dimensioning and tolerances in design. Here are few applications of GD&T in design. First, to isolate and define the functions of the features or part. Second, to prioritize the functions. Third, to identify the datum reference frame based on functional priorities for defining the dimensions and the tolerances. Fourth, to select the proper controls like form, orientation, location, runout, etc. Fifth, to calculate the tolerance values by following BIS system of fits and tolerances. Geometric dimensioning. It is important to specify details about the shape and size of a component. Shape is specified by orthographic drawings and size is specified by dimensions. It is the responsibility of the designer to communicate his or her intent clearly by specifying appropriate dimensions, tolerances in the drawing before his or her team. The team may comprise of manufacturers, machinists, metallurgists, quality control engineers, suppliers, etc. The unit system used in India is millimeters in general. It is important that drawings are preferably drawn using first angle projection, as well as the statement that all dimensions are in mm is mentioned in the drawings. Now let us understand what is a dimension. It defines the geometrical characteristics of or a size of the component. A basic size. It is a theoretical value that states the exact dimensions of component. What is reference size? It is a numerical value in parentheses which only gives information and should not be used for fabrication. Significance of dimensioning. Size dimension. It states the overall dimensions of the component. It may be represented as horizontal, vertical, diameter and radius in case of circular components. Location dimension. It specifies the distance and orientation of a feature in the component drawing. It can be horizontal, vertical or angular. What are the standard practices for dimensioning? All dimensions should be outside the component. If they are identical features with the same dimensions, then a number of features multiplied by diameter should be mentioned. Tolerance. Tolerance is the amount a dimension can vary and the difference between minimum and maximum limits. The advantage of tolerance is that it allows interchangeable parts. Here are few important points which should be remembered while studying tolerance. Nominal size. It is a dimension which is used to describe the general size and it is expressed in fractions. Basic size. It is the theoretical size which is used as a starting point for application or implying tolerances. Actual size. It is the measured size of a finished part after machining. Limits are defined as maximum and minimum size shown by the toleranced dimensions. Allowance is the minimum clearance or maximum interference between parts. Tolerance is the maximum difference the dimension can vary between upper, that is maximum, and lower, that is minimum limits. Maximum material condition. It is the upper limit of an external feature, that is a shaft, or a lower limit of an internal feature, that is the hole. Least material condition. It is the lower limit of the external feature and the upper limit of the internal feature. Let us understand maximum material condition and least material condition. Here we have the engineering drawing of the component and the machined part. The actual measured dimension is 0.501. The external feature as studied earlier, the maximum material condition is the upper limit and the lower limit is the lower material condition. In case of the slot, the upper limit is the lower material condition and the lower limit is the maximum material condition. Tolerances. How can we define tolerances on drawing? First, direct values applied to dimensions or direct limits like 10.53 and 10.49. Geometrical tolerances by specifying 10.00 plus or minus 0.003 and notes referring specific conditions like presence of a datum plane, concentricity of a particular feature with the another feature. Tolerance types. Tolerance are broadly classified as form, orientation, location, profile and runout. Form are further classified as flatness, straightness, cylindricality and circularity. So let us understand each of them in detail. What is flatness? It controls the flatness of a surface to its perfect form. Straightness, it controls the straightness of a feature. Circularity, it controls the form of a revolved surface, and cylindricality, it applies to the entire surface. Location. Position, it controls the location of a feature in reference to the datum frame. Symmetry, it controls the symmetry of two surfaces in reference to the central datum. Concentricity, it controls the surface of revolution in reference to the central datum. Orientation. Angularity, it controls the orientation of a feature at a specific angle in relation to the primary datum in its datum reference plane. Parallelism, it controls the orientation of a feature which is nominally parallel to the primary datum of its datum reference frame. Perpendicularity, it controls the orientation of a feature which is nominally perpendicular to the primary datum of its datum reference plane. Profile. Profile on a surface controls the size of a feature as well as form. It also controls location and orientation when the datum reference plane is used. Profile of a line, it applies to the cross section of the feature. Circular runout, it controls the circularity, coaxiality or each circular segment independently about the coaxial datum, and total runout controls straightness, circularity, coaxiality, taper of a cylindrical surface about coaxial datum. Here we have been constantly referring to the word datum. So what is datum? Datum is a theoretical exact point used as a reference for tabular dimensioning. Here are few other modifiers which can be used to mention the details in the drawing. The letter M can be used for maximum material condition. The letter L can be used for least material conditions. REF in brackets can be used for reference dimensions, and the datum plane should be referred by using the following symbolic representation. The following presentation has been made by studying the references Design of Machine Elements 3rd edition by V.B. Bhandari, McGraw-Hill Publications, Dimensioning and Tolerancing PDF from engineering.tcnj.edu and Machine Design by R.K. Jain, Khanna Publications. Thank you very much and wish you a happy learning.